Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous topic we have discussed about the numerical based on the decay constant problem number 8, and now here we are going to talk about the problem number 9. This problem is very different from that of the previous one, and let us see this question first. So friends, this is the question that has been asked for, that is the half-life of the polonium 209 is 102 years. How much 1 milligram sample of polonium 209 decays in 62 years? So this is the question that has been asked, and here basically what we have to do is we have to find out the amount that has been decayed during this 62 years. So for that we have certain details, and that is the half-life for this polonium is found to be 102 years. So what we can do is we can write the values, that is T half is equals to 102 years. This Y represents years. How much 1 milligram of sample of polonium decays in 62 years? That means the time is also been given over here, that is within a period of 62 years we have to calculate that how much it will decay if the initial concentration, or if we could say if the initial number of the polonium in terms of milligram, which has been found to be, that is I could write it here as N naught, is 1 milligram. So here basically we have to calculate, obviously we can calculate the value of N, and based on that we can find out that how much milligram of sample has been decayed throughout this 62 years. So this is what we have to do. So let us first of all find out the value of the lambda, that is the decay constant, because unless we find the value of decay constant we cannot get the value of N. So let us find out that first. So here we are going to talk about how we can calculate the decay constant, but for that we have a formula, that is T half is equals to 0.693 divided by lambda, that is the decay constant. So therefore let us find out the decay constant here, that is lambda is equals to 0.693 divided by T half. So here basically the T half for the polonium is found to be 102 years. So I could calculate this thing, 0.693 divided by 102 years. So therefore we could get the unit of the decay constant here as year inverse. So let us see what is the value we could get after calculation. So here we have got the value as 6.794 into 10 raised to minus 3 year inverse, that is for the decay constant. So this is the value, that is what we have got, but this is not the only data, that is what we have to calculate. Obviously we have to calculate that is how much amount of 1 milligram of polonium has decayed throughout 62 years. So let us understand the formula first, and let's see how we can calculate it. Since we know the formula, that is lambda is equals to 2.303 divided by T log to the base 10 of N0 or N naught divided by N, and here basically we don't know the value of N. So therefore we know the value of lambda as well as we know the time or the duration in which this change will occur. So therefore we have got the value of the decay constant, which is found to be, that is 6.794 into 10 raised to minus 3 year inverse is equals to 2.303 divided by the time, that is within the duration of 62 years. So I could write it here as log to the base 10 N0 divided by N. So since if we have to calculate the value of N, obviously it should be free from the log. So one thing that we can do is we can multiply 6.794 into 10 raised to minus 3 with 62, and again we can divide it with 2.303. So in that basis we could get the value of log N0 divided by N. So therefore the value of log N naught divided by N, it will be 6.794 into 10 raised to minus 3 multiplied by 62, the whole divided by 2.303. So let's calculate this and let's see what is the value of log of n0 divided by n. So we will get the value of this as 0.1829 for log n naught upon. But this is not the final answer. Obviously, we have to calculate the value of n. So one thing that we can do is we can shift this log on that side, and that's the reason we could get the antilog of this, and then we could get a pure ratio of n0 divided by n, which is free from the log. So let's see what is the answer we could get. So after taking the antilog of 0.1829, we'll have got the value as 1.524. But this is the ratio for n naught divided by n. And already we have got to know that is the value of n naught is nothing but it is 1 milligram divided by, I could make this to come over here, that is 1.524, which is equals to n. So therefore the value of n, that is the particle which is left after the decay, is 0.656 milligram. But again, still this is not the complete answer, because they are asking for how much amount has been decayed from 1 milligram to a particular amount within the duration of 62 years. So what we have got is, we have got that is within 62 years 1 milligram of the polonium has been decayed to 0.656 milligram. That means the decay that has been occurred during that process can be calculated as, since it was 1 milligram that is initially we had, and this is the final particle or final amount, that is what we have, which is 0.656, and once if we calculate this value, we could get the value as 0.344 milligram was decayed during that 62 years. So this is how basically we can solve the particular numerical, and that's it. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.